Hey everyone, how are y'all doing? I'm Shai. I'm a developer advocate at Docker. I'm really excited to be here today to teach you pretty much everything I know. And I've only been at Docker for about 3.5 months now, so it's not everything yet. I'm working on getting there. But yeah, I'm really excited to have y'all in this workshop and for y'all to learn all the things that I've learned. I see I've got some friends in the audience. I see Joe Nash in there. I see some other folks, Philomath 10, Vishnu. I'm really excited to have you all here as well. Feel free to jump in with questions at any time. Mary is going to be my question reader, so she's going to jump in whenever you all have questions and interrupt me. I figure since we've got an hour, we can be pretty chill here. I've got like a PowerPoint deck that's like 6 slides long, and then I was planning on just doing some live coding. And so if anyone has anything they want me to build or want me to make, I figure that could be a fun thing that we could do together, and we could run through how to make it using Docker. If no one has any suggestions, I've got like a little demo project that we can run through. I've got some Raspberry Pis and some cool like IoT screens at home that I can show off. But if anyone has any ideas or anything they want to do, we can make it happen. So cool. Let's jump in and talk about software containers. And I think this is a really fun time to actually talk about it. So Docker's doing has been around for a while. We just turned 9 a couple weeks ago, so we've been dropping birthday cake emojis and stuff left and right on our Twitter feed as well, which is pretty fun. I'm Shai. I'm a developer advocate at Docker. I used to be at Contentful, and before that, I was at MLH, and I figured this was a good opportunity for me to break out my old MLH shirt. It's gotten a little peely, but I still love it. So, so I'm really happy to be here. I'm really excited. So, raise your hand if you have had any of these problems. And since we're streaming this, I really mean like give me an emoji reaction of you looking stern if you've had any of these problems before, right? Let's say you have an application and it doesn't work in the cloud like it does on your machine. You've built it on your MacBook, you've built it on your Windows machine, and you push it out to AWS, you push it out to Heroku, you push it out to Netlify, and it just doesn't work. Maybe you have to jump in there and you've got to upgrade a machine or a server or a virtual machine. Maybe you've got to install an operating system. You got to keep all those dependencies up to date. And that's all that stuff before, you even get into like actually running the program. You haven't even gotten a chance to configure things. It's just painful. Folahack is right. It is just pain. And if you want to switch clouds, that's a huge problem too. Let's say you go to one hackathon and you've got your free AWS credit, and you go to the next hackathon and you've got your free Google Cloud credit, because you get so much credit as a student, and I'm so jealous that I don't get all those perks anymore. Y'all are really lucky, and you got to take advantage of it. How do you switch between those providers? How do you do it? It can be really complicated. It can be really difficult. Once it's up, it can be a pain to keep it running. It can be a pain to keep it up to date, and then you've got to work with your teammates at your hackathon to get it all collaborative, and that can be a nightmare too. I think software containers are really one of the nice solutions to this thing. So containers let you package up your code, your dependencies, so they all just run. So think of it literally as a storage container, right? And inside that storage container is everything that you need to make your program happen. So it's the dependencies that you need to run Python. It's the dependencies that Pip will install. And you can take that container and run it using the Docker engine, which is a pretty available software source. It's on pretty much all the clouds at this point. So you're able to just take this container that runs identically on your machine and run it just in the cloud, or on your friend's laptop who might be using Windows while you're using Mac. So it's a way to containerize kind of your applications and basically make this holistic thing as well. And you might think this sounds kind of like a virtual computer, but it's not really it's not quite a virtual computer, right? Containers themselves are boxes. They don't have like operating systems. So it doesn't really matter what device it runs on. And you build these things by building these Docker images, which are like templates or like a run book that has everything you need to actually make the container. So an image is kind of like a set of instructions for building a container. And unlike a VM, you don't have to allocate resources dedicated to the thing. So you can reuse and reshare resources on your machine. You can even use like some of the lower level stuff in a container across other containers. So you don't necessarily need to have like 4 copies of Ubuntu running at the same time. You can just kind of use the Ubuntu base image, and you get to really slim those things down. So you aren't necessarily always using gigabytes of space as well. So we've got Docker Hub, which is a great place where you can go to find Docker images. We've got all the fun ones. They're run officially by the folks that are in charge of the software. So the Python one, for example, is run by folks who work on Python, and we're always keeping it up to date and make sure that the things that you're using are secure. Folks are asking in the comments about pricing with Docker, which is a great question. Practically, Docker, functionally for like individual student use, Docker is free. You don't really have to start paying for Docker until you're running into like big teams in like company settings. So if you're just doing stuff for student projects or just for fun, basically Docker is functionally free for you all. It's kind of like GitHub in the way that like GitHub is free, and whenever you start using it professionally, your organization can start paying for it as well. So got another question from the audience, from Arpandit Aditya. Sorry if I pronounce that wrong, but the difference between Docker and a container. So Docker is like an engine that runs the container and will package up the container for you. So they kind of work all together. So I think that's enough PowerPoint. If y'all want more PowerPoint, I have more PowerPoint, but I figured we can keep going and we can jump into writing code if y'all are up for it. Give me some raised hands emojis if you want code. That kind of sounds cool. I'll take it. I will take it. So I do want to ask y'all, like, is there something you want to see built? I can run through my Docker as an organization. Docker is like an open source tool, and then we have Docker as a company that kind of runs and maintains that tool. As well. Docker is not Kubernetes. So Kubernetes is a way of running. So I'm not a Kubernetes expert. So like full disclosure, I don't know a ton about Kubernetes, but Kubernetes is like a distributed architecture thing. It's like a way of running deployments, and Docker does have some stuff that works with it, but Docker and Kubernetes are like totally different there. So Docker, I think, is originally like a Google thing, sorry, Kubernetes is originally like a Google thing, but Docker is totally like its own different alternative way of running and packaging code up as well. So okay, so here's my code, and I want to talk about this project already. So 45145V is asking, can we get pre-built templates like you said for Python? And yeah, we can. So let me run through my application really quickly, and I think that'll show you kind of what I mean. And let me actually just pull up the GitHub repo as well. So if y'all want to follow along on GitHub, you can do that, and I'll chuck it in the comments, or maybe Mary can chuck it in the comments for me as well. So this is my project here, and I will private chat it to Mary, who can chuck it in the comments. So yeah, so this is a project that I use to kind of keep an eye on the vaccination rates that are going on in the world. So I'm like deeply curious about like the vaccination statistics. So I've got these physical little e-ink ESP32 screens. So they only have like 2 megabytes of SIRAM. So they don't have a ton of room to do a lot of compute on. So, but the screens are really nice. They're kind of like if you ever go to a Best Buy or a store that's like got those e-ink screens that like update with the prices and the sales and all those things. It's kind of like that. So they let you run Python on them. There's an organization based out of New York called Adafruit that builds them, and Adafruit is awesome. I'm a huge fan of like pretty much everything they build as well. So what these things do is they reach out to Our World in Data, which is an organization that compiles vaccination data from around the world. They compile a lot of data. They have a lot of big data sets available. And one of the problems I have with the OWID database that they run about COVID rates is it's pretty big. It's 34 megabytes right now, and it contains all sorts of historical data. And you might think 34 megabytes, that's tiny. Whatever, Shai. You're like overhyping the size of this thing. You can handle it. PyDude asked, like, are they data scrapers? I would consider them more like data compilers. So, like, we've got the CDC in America putting out vaccination data, and then we have the NHS in the UK doing it, and all sorts of different organizations around the globe are putting it out in different formats, and they kind of take it, merge it all together, standardize, normalize it, and they do some compiling as well, so you can get aggregate data on things like the world in general. So they're really cool. Pi 314 dude says that 34 megabytes is large to process this text data, and he's totally right, or she's totally, or they are totally right as well, because this thing has 2 megabytes. I can't deal with that using this thing as well. So what I built is I have a little Flask app that I'm running on my Raspberry Pi. My Raspberry Pi is plugged in right over there, so I can't show it to you because it's also hooked up to some GPIO pins to a thermal printer, and so I can't move it super easily. But that Raspberry Pi is running a Flask server that reaches out to it's a Pi 3 Model B that reaches out to the OWID database, and so SmartMind is asking, does container run on bare metal speed? I don't know that off the top of my head. What I do know is it reduces the distance between like the project running and the actual hardware as compared to like running a virtual machine as well. And you can allocate more resources to it as needed. Or just run it on like bigger machines if as needed. So like it's kind of like a different way of running things. But I'm not super sure about that off the top of my head. So where was I? What was I talking about? So I'm running this Flask server, right? So it's running on the Raspberry Pi. The Raspberry Pi is taking this 34 megabyte file, and it's basically just grabbing like the minor data that I need. And so I'm running this actually on my local network right now. So we can go to Raspberry Pi, raspberrypi.local/5000, and maybe we can hit the data for the United States as well. Something really cool I learned that I'm super into is that you can just go to raspberrypi.local and it'll just work, assuming you don't change the host name. So yeah, here we go. We've got the vaccination date for the United States in general. So we've got a fully vaccinated per 100 of 65.7%, which matches kind of what I have on this screen here. And it's pretty quick because the Pi can handle files fairly quickly. I don't have any caching on here or anything like that because I'm lazy, but I could totally set that up if I really wanted to. But it's only, my IoT screen's hitting it, so I don't think it's a huge need there. So I've got my Python code, and we can go ahead and get this thing working on my MacBook, right? And the architecture of my MacBook is different than a Raspberry Pi. And so keep that in the back of your head as you're thinking about this or as I'm talking about it, because that's going to become important in a little bit. So I've got my application, and I can run this with a standard like Flask run. I've got my environment variables hidden in a .env file that I'm not going to show you because it has some credential stuff in there, and largely it's not that important. There's a version of it in that repo that I think should be safe. So I can run this with Flask run. And am I in my right? I got to set the app. Well, we could just do an old school Python app. There we go. So I've got my server running on this IP as well, and it builds and everything, and that's great. So I know it works. So let's go ahead and do some Docker stuff here. So I'm going to go ahead and take a look at my Docker file here. So here I'm kind of declaring when I build or compile this image into a container, what do I need and what do I want to happen? So here I'm using Python 3-slim, and we can go back to, or we can go take a look at Docker Hub really quickly. And someone earlier was mentioning pre-built templates for using things. And this is I think they were, who was talking about that? Pi 314 dude, I see that, and so was 45145V. So this is Docker Hub, and I should already be signed in. We'll see. There we go. Okay, so I'm signed in, and I can go ahead and I can start searching for images that I want to use for my project. So I can see here that we've got this verified publisher and the official images. So official images are from Docker. Verified publishers are folks that are generally associated with the things that they're building. So I believe like the Node community is maintaining the Node image as well. Circle CI are the ones deploying their own version of Node as well. So we can click into Python, and we can see that we've got a bunch of different things that we could use here. So if I just typed in Python, I would get the one of these images. I'm using Python 10, so I'm going to grab one of the Python 10 images, and I like to use the slim image because it kind of just reduces the size of the image to kind of the bare minimum that I need. So it'll reduce the container from maybe like a gigabyte to like 100 megabytes or something like that. It's like the least amount of stuff that I need to get Python running anywhere using Docker Engine, which is really great. So I'm starting here with this official Docker image, and I can pull this. So I'm going to start with this base image of Python 3 Slim, and then since this is a Flask app, I'm using port 5000. So I'm going to tell Docker that you should expect that port 5000 is going to need to be exposed. I'm going to go ahead and set up a work directory. So this is where all my code is going to live. And then I'm going to go ahead and copy my requirements file into that work directory. And then from inside Docker, I'm going to do an install of all my dependencies. So kind of how you would do an install of dependencies with if I was running this locally or if I was running this in a virtual environment, we can do the same thing here. So now I've got this slim Python image that also has the dependencies that I need to run this project. And then I can copy all the other code over. So I can copy the rest of my code over, and then I can tell my image, okay, this is what I need you to happen when you run the application. I need you to do Python 3, since it's a Python 3 app, and I want you to start on that app.py file. So let's go ahead and actually build this and go ahead and start seeing stuff in action, which should be fun. So I'm going to start with Docker. And let me make this a little bigger for y'all. Let me just pull up my real terminal as well, because I think that's a little bigger. And I can zoom in a little. Oop. What is the zoom command? Is it? Oop. View zoom. Make text bigger. It's Command plus. Command Shift. Cool. So that's nice and big. So hopefully y'all can read that as well. So yeah, to get started, I'm going to go ahead and get started with let's take a look at Docker and see what we get. So we've got a bunch of help functions that we can use, and we're going to be doing a build. So let's go ahead and take a look at that Docker build command. So we've got build right here, and it says build it from a Docker file. So let's make sure we are in the directory with the Docker file. Yep, we've got it right there. So let's do a cat. We can take a look at it as well. So let's go ahead and take a look at what Docker build does. So dash, I think it's dash H. It might be dash dash H. Okay, so Docker, it's build dash dash help. Cool. So we can build an image from a Docker file, and we have a couple options. We can use this tag, which lets us name it. We can say what the path is right here. So we've got our options, we've got our path. So let's go ahead and do a Docker build, and I'm going to go ahead and name it Shai Ruparel dash, if I could spell my name correctly. The hardest part about coding is spelling your own name, or just spelling consistently. So Shai Ruparel, and we can call it Hello World and I'll set it to the latest image. And then I want to move everything in this app directory in the build. So I'm going to use the dot function to let it know I want everything. So Docker build, and it's going to go ahead and start creating it. So here we go. It's downloading the latest version of the Python Slim image. It's going to go ahead and make that work directory. It's going to copy things in. It's going to run pip. And I have the cache disabled, so you can see it happen live. You don't necessarily need to do that when you're using it. It's going to copy all the code, and it's going to export it into an image, and it's going to set that name. Now, I can run this from the command line if I wanted to, using a Docker run. But what I'm going to use instead is I'm going to pull up Docker Desktop, because it lets me kind of see all of this stuff in person, and it lets me click on it. So let's go ahead and sort this by created. And we can see we've got my Hello World application right here. And I'm going to go ahead and click Run, and I'm going to set the optional settings here to expose port 5000, so that way I can connect to the application. And I'm going to leave the rest of this alone besides the name. Hi, Global Hack Day. That's what we'll call it as well. And let's go ahead and run it. So it's going to get started, and Docker is going to start running this container for us. So I am going to go ahead and click into this, and we can see kind of what's going on. We can see the logs here that it spun up the Flask application. It's set an IP for it. It's set it to 5000. And now if I go to this IP, nothing should happen. But instead, it's going to be mapped. It's going to be mapping this internal IP inside the container to my local host on my machine. So if we go ahead and we pull up Firefox again, which I think should be here. Yeah. So we've got this Raspberry Pi.local, and instead I'm going to replace it with localhost, and we should get pretty much the same result. So yeah, we got the same result, and maybe I'll just swap into the UK. Oop, that's going to 404 because that's not an ISO code. It might be GB. Let me try GB. Oop, it might not be GB. What's a good ISO code off the top of my head? Okay, we can do world. So OID world. So yeah, this is, oh, that's not my local host anymore. That is the Raspberry Pi again. So yeah, localhost. And we can see that it's mapping this port 5000 on my external machine into the container that I'm running. And I can change that container so it points somewhere else, which can be useful if you're like doing, multi-architecture things or developing things that need different ports, or like 4 Flask apps at once as well. Internally inside the container, they're all using 5000, but you can map that port to anything outside of that as well. So I have this built for my MacBook, which is running a different architecture than my Raspberry Pi. So let's go ahead and, well, first off, why don't we pull up the terminal and poke around on this thing a little bit. Maybe we can take a look at what's going on. So I can do a Docker container ls, and we can see that my container has been running there. It's been going for 2 minutes as well. It's got a name. It's got an ID. As well. And so maybe we can look at the logs from the terminal as well. So we can do a Docker hello world log, Docker logs, and then hi global hack day. And we can see those logs that we were looking at in the terminal. We can use, I think there's a Docker CTOP is the program. Nope, CTOP. So there's a couple community tools out there that you can dive into to like really get in detail and see kind of the CPU health as well. So I like to use one called CTOP, and we can see that since it's a pretty minor container, it's not really doing much. I assign half my RAM to Docker just to let it take it. And so like we're using like 73 megabytes of my RAM right now, which isn't a ton as well. So yeah, that's I think pretty cool. So we're gonna take this image, and what we're gonna do is we're gonna go ahead and rebuild it. But instead of building it for my MacBook, we're gonna build it for the Raspberry Pi, and then I'm gonna SSH into my Raspberry Pi, and I'm gonna go ahead and pull that and then run it as well. So let's go ahead and do a Docker build. And we can look at help again to see what it tells us in the command line. So we can see that there's this platform. So we can set the platform if it's multi-platform capable, which in this case it is. So I'm going to do a Docker build -- platform, and I'm going to pick Linux. I'm going to pick ARM because that's the what's running on my 3PI-B. I'm going to set the tag. I'm going to use my name because I'm going to eventually push this up into the cloud. I'm going to type in Flask and our world and data parser, and I'm going to set the tag to ARM v7. So I can pull that build specifically. And then just like before, I'm going to copy everything, or I'm going to build it here where I'm at right now. And I can also build it for my MacBook at the same time as well if I wanted to. But for right now, I'm just going to build the ARM version. So like before, it's gonna pull the Python Slim image, and it's gonna copy those things over. This one is gonna be a little slower than before, but it should still be pretty reasonably fast as well, since this is a fairly lightweight application here. And you could set whatever you want here as well. So if you're building on a 32-bit machine and you need to do something on a 64-bit machine, you can do that and then push the image as well up to Docker Hub. And so this is going to take just a second. Can we integrate TCP protocols in Docker while deployment? I'm not sure what you mean by that, but I will say like this is using TCP. So it's mapping my local 5000 over to the 5000 TCP inside the container that we built. So I want to say the answer is yes. And if you want to get inside that container as well, so I can pull up Docker Hub as well. And one of the things we can actually do is we can connect directly into the CLI of that container, and it's kind of coming across screen. So let me move this to my other screen. So you can see that it generated a command that like SSHs into the screen, and now I'm kind of like poking around in the container, and we can maybe go into Python 3, and we can check like Flask import Flask, or what is it, from Flask import Flask. Yeah, and so like that just works because Flask has already been pre-installed on this container. Sorry, typing is difficult. And yeah, and then we're here, and this is just running, and we can do whatever we need to. So if you need to like mess around or practice, like hey, I want to just double check my installs are working, or this isn't working, and I want to go into it and mess around with it, we can definitely do that. So let's take a look. We can see here that it has finished building, which is great. So I'm going to go back to Docker Desktop. And again, I can do all of these things in the command line if I really wanted to. I just find clicking things is a little easier sometimes. And we can see actually down here, the time I made this without using the Slim image, it was almost a gigabyte, but using the Slim image kind of drops the size pretty substantially. And this has everything that it needs to run. As well. So you could move this Docker image to any machine and it should just work. You might just need to build it for whatever platform you're running as well. But yeah, so I'm going to go ahead and push this to Hub. So we're pushing the ARM7 version, and this is going to take just a second because it's going up to the internet as well. And cool, so it's up. And if we go back over to Firefox, we can go over to Docker Hub. We can click into my account. And we can see that we just updated this a few seconds ago. The new ARM v7 version just came up, which is pretty cool. Some of the other things that we could do while we're here that are pretty fun is we can actually see what kind of vulnerabilities that I've got running as a problem on this repo. And most of the problems actually just come from the Python base image. So they're not really things that I can resolve. They're stuff that the folks upstream that are running the Python image would need to help out with, or the pit, the pit packages that I'm running. So we can click into this and we can maybe take a look at some of the vulnerabilities that we've got here. And so you can kind of see them straight away. And if you're building production stuff, this is really nice because then you can go in and figure out, okay, I need to start dealing with this stuff. So we can see here I'm using the ImageMagick library, which is causing a bunch of problems. There is some more stuff that's running because of ImageMagick. And so like one of the things I might decide to do is maybe just stop using ImageMagick and maybe find a library that has less vulnerabilities as a way to drop some of these issues as well. So, and we can take a look and see what the container is doing as it builds. And so this looks like it's all stuff from the Python image, the base image, and then we should switch over to the stuff that I'm doing as well near the bottom. So yeah, you can see here it compiles it, it makes that Python image, and then we go over to my stuff, which is creating that work directory, copying my files over, running my stuff, and then this is how I run it itself, which is pretty fun. And we can see kind of where the memory is coming from too, or how it's getting used as well, which is pretty fun. Cool. So let's go ahead and get this running on the Raspberry Pi. So let me pull over my terminal again. So I went ahead and just pre-logged into my Raspberry Pi because I figured y'all don't want to see my password to my Raspberry Pi. I promise it's not Raspberry anymore. I did change it. So we've got some stuff on here, but more importantly, let me just go ahead and see what's running on this machine. So right now I am running a version of this container. So I'm going to go ahead and stop it. I'm going to go ahead and do docker stop and then the name of the container. So docker stop Flask OID parser. And this will take just a second. It's a little slower than my MacBook because it is a Raspberry Pi. It's nowhere near as nice as my Pi. So here we go. So and now if we do a docker container ls, we can see that nothing is running. So I'm going to go ahead and refresh this e-ink display. I can just hit the reset button, which will cause the code to rerun. And it shouldn't give us anything because it's not going to have anything to connect to. And maybe I can just show you the code that's running on here really quickly too, just for fun. So here we are in my repo. It's got the mag tag area, which is just the code. And the nice thing about this is all you have to do to get it to run is just copy paste it onto the thing. It's got a USB-C port on the side that you can plug into your computer and then just copy paste the code. And you can see that it failed. It's got like it's kind of hard to see with the lighting in my apartment. But you can see that it's got like a black screen, so it's got some error messages here. It's saying sending a request failed, which makes sense because there's nothing running on my Raspberry Pi port, and we can actually maybe take a look at that really quickly too. So Raspberry Pi local 5000, it is down because there's nothing running on that Pi right now. Cool. So what I am going to do is I'm going to go ahead and pull this image, and then I'm going to run it on the Raspberry Pi. So let me pull up my Pi again. So we've got Pi at Raspberry. It's not nearly as nice looking as my personal terminal, but I think it should be pretty good for what we need to do. So what we can do is a Docker. Well, let's take a look at Docker again and see what commands we get. And so we can do a Docker pull, and we can pull from a registry. And the nice thing about this too is that like I can get this from Hub as well. So I can do a Docker pull, and then it kind of explains this how it works to me. And I can switch it to the public view, so it's showing me the commands I need. So I can do a Docker pull, and I can copy it. So here we go, and I'm going to set the tag to ARM v7 because that's the version that we need to run on this machine, is the ARM v7 version. So it's going to pull, and it's going to take a little second here. Here we go. There's a question about volumes are created so non-Docker entities don't have access. So volumes are an interesting concept that I'm not going to go into today, but let me give you an example of how they can be useful. Let's say you're building an application with databases, right? And you want to be able to maintain storage. So let's say, for example, I added caching to this application. So Python has a really great caching library that uses SQL to kind of run that cache and track the validations of that stuff, which means I would need to set up a SQL database. Now, the problem with Docker is that when I rebuild the image, it's going to create a new SQL database for me every time. And that's where volumes come in. So that way I can have like the data be persistent and it'll rerun SQL for me using Docker. And that SQL command is going to connect to that volume and know, okay, every time I'm running, this is where the database lives. This is where the data itself lives. And the I'm teaching in such an easy manner. That's funny. Sorry that the stuff is scaring you. I don't mean it to be scary. I'm sorry about that. That's really funny as well. So yeah, volumes are really useful, and they're really cool, especially if you're starting to do stuff with. So SmartMind points out that creating new SQL would take a lot of space. Yeah, it would, but you can define kind of how that volume is going to look, how big it is, and you're just going to be keeping that volume around. So every time you're generating a new build of SQL and you're running a new container of SQL, but that sense is that isn't necessarily the part of it that's really heavy. The part of it that's really heavy is the actual data store, the volume, and you can rebuild and recreate your SQL database as needed, and just know that like the data is always going to be persistent. You're not going to need to rerun your migration scripts or anything like that if you don't want to. So it looks like our pull our pull is done. So we've got it. We've downloaded the newer image that we just pushed up. So let's go ahead and do a Docker run. So we can run this command as well. Or actually, let's just do Docker images. Let's see what we've got on this machine. So we've got a few images that are on this machine because I've been mucking about with stuff. So we've got this tag, this ARMv7 that we created 8 minutes ago. As well. And so I can go ahead and I'm going to run this image on my Raspberry Pi. So I can do a Docker run. And since I'm hooked up to the Pi, I can't use the Docker Desktop tool. I'm gonna have to use the CLI. But we are building, or we are working on Docker Desktop for Linux. It's in beta right now, and you can use that if you've got a Raspberry Pi. You can use that if you're running your Raspberry Pi and have it connected to a monitor. I don't have it connected to a monitor that I can capture, so I'm stuck with the terminal, unfortunately. So we can do a Docker run, and let's go ahead and take a look at what Docker run lets us do. And maybe I can explain some of the things here. So in Docker run, I can see that, let's take a look at the ports because we did ports last time. So I can see here that -p gives me the option to publish a container port to the host. So that means I can expose that, I can take that 5000 port that I exposed in the Docker file, and I can attach it to a port running on the Raspberry Pi. So when I go to that Raspberry Pi.local 5000 or whatever port I do declare, it'll connect to the one that the Docker build has exposed for me, which is really useful. The other one that I want to pull out is I want to talk about -d. So what this does is it lets you run the container in the background. So if I do a Docker run and I don't do a -d, it'll be like a trailing log. So why don't we do that really quickly? Docker run -p 5000. So I'm exposing the port 5000 on my Raspberry Pi to the port 5000 in the container. I'm going to go ahead and name this, and I'm going to just call it hi GHD, and then I'm going to tell it which image I want it to run. So Shai Ruparel, Flask, and it auto-completed, and then I'm going to say I want it to run the ARMv7 version because that'll work. And now if we run this, we can see that it's gonna trail us the log. So I can click on I can go over to my Raspberry Pi, Raspberry Pi URL, and we'll be able to connect to it. So why don't we do that really quickly? We can go back to this failed localhost. Oh, this is the real localhost. So let's go ahead and change this to Raspberry Pi.local, and we can go there, and we can see that it's working, or we will when the page refreshes. What did I do wrong? Raspberry Pi local, and we can go to ISO and USA, because I'm looking at the USA data. And cool, so we can see that we hit it, and if we pull over, we can see that we're getting those, we can see that GET request happen as well. And so as soon as I disconnect to this in the terminal, it's going to stop running, which can be useful sometimes, but sometimes you want it to run permanently. So I'm going to Control C. So I don't have anything in my terminal anymore, and it's gonna 404 because the Raspberry Pi isn't doing anything. So using that -d detach command can let us get around that issue. So we're gonna detach it, and it'll be running in the background and get added as a background process on this Pi. So we're gonna do Docker run. And I need to rename it something different. So hi GHD. I can just get rid of that. Docker container rm hi GHD. Cool. And then we can do a Docker run again. Cool. So it's giving me the ID of the container. So if I do like a Docker container ls to see what containers are running on my machine, we can see that they match. So if I do a Docker rm of like the first of this, it'll delete that for me, or I can just use the name, which is why I set the name, because the name is a lot nicer for me to look at. So we've got the Docker container. It's running in a detached state on port 5000. So it's going to connect from port 5000 on the Raspberry Pi to the container at port 5000. And it's running a build that is specifically designed for the Raspberry Pi. So if we reconnect to this, it should load. And I'm going to go ahead and reset my mag tag. So it should go ahead and hit the Raspberry Pi and start updating with data. Now, these mag tags are pretty slow, so it's going to take a second. Getting an error is really fast, but getting it to work is a little slow as well. While we wait, maybe we can take a look at some of the chats. So my terminal here acts as the Docker client or host. So my terminal moves me into my Raspberry Pi, and I have Docker installed on my Raspberry Pi. It's using the Docker engine to run the image, which creates the container. So Docker engine on the Pi is running kind of my code for me as well. And we can see that the mag tag just refreshed and we've got our data again. And we can see that I can keep a lookout of kind of what's going on in a format that these tiny little devices can do for me, which is pretty fun. Okay, and let's see what other questions we've got here. I see y'all are having some great conversations with each other, and I don't want to jump in the middle of it as well. For folks saying that maybe this is a little difficult or this is a little complex, don't worry about it. This stuff I know is a little out of scope. This is the kind of stuff you do when you start working professionally. It's not necessarily that you need to know it while you're still a student. It's a nice thing to learn and to use as you're learning and becoming computer science professionals. But it's definitely just one tool that you need to know. Kind of in the same way that you have to learn Git, and that's a little complicated as well. So we've got a question from utom22. Can't we run an image directly from Docker Hub so we can share it with our friends? So Docker Hub is a storage kind of location for images. So you can push your images to Docker Hub, and then you can send those Docker images to your friends. So you can share the URL with them to your friends. So I'm going to Slack this over to Mary, and Mary can chuck it in the chat or in the comments for me as well. So yeah, this is just a public thing, and you can do a pull, and I should probably write a better README for this thing. I have a good README on my GitHub, but you can just pull this image right now, and you can run this code on your machine. And there's a build in here for not Raspberry Pis, and there's a build in here for ARMv7 as well. So you can use both of these as well. You can say specifically, I need an AMD 64. I don't have an M1 build. I should probably put an M1 build together. But alternatively, you can just go to the source code over on GitHub, and you can download the repo, and you can do a build on your local machine. And that'll just work. So you can go into this Docker app, you can do a Docker build like we did earlier in the demo, and it'll build based on this Docker file. And if you don't specify the platform, it'll pick whatever your machine is running, so you'll be able to run it locally. So we've got this running on the Raspberry Pi. We've connected to it as well, which is pretty fun. I'm going to go ahead and switch back to my PowerPoint really quickly because I've got some stuff to give away, which might be fun. So let me go ahead and go back into slideshow mode, Command-Shift-F. Oh, cool. And yeah, so I've got some t-shirts to hand out. There are 50 of them. So that top link will take you to the Docker Swag store, and you can use that coupon code. It'll come with free shipping and a t-shirt. As well, or it'll give you a discount for free shipping and a t-shirt. And then that bottom link is kind of where you can get started and where you can learn more. But I would love to hear some questions from y'all, and maybe y'all can have a chance to grab some shirts or let me know what's going on there as well. So let's see what we've got in the questions. I thought of it as GitHub. Thank you for clearing the doubt. I'm glad to help hear that I clarified things for you. That's really great. What else do we have in the questions? Are there any good questions as well in the chat as well? Utam says that the CLI is a beast. Yeah, I like CLI stuff too, but sometimes it's nice to have things to click on. So the top link there is for the t-shirts, and the bottom link is for more information about getting started with Docker. It's a download link that'll help you download Docker Desktop and install it. And then you can get started learning and using it, and hopefully it'll make it easier to collaborate with your peers, especially if you're on different machines. It'll let you kind of bundle up your code in a way that makes it rerunnable between different stuff. So what's Docker mainly used for? That is a great question, and I think that means I didn't answer it. But Docker is a great way of making sure that your code on your local machine runs consistently in the cloud. So you will be writing code, and you've got like a bunch of different teammates, and then when you need to deploy it, rather than having to go into AWS and configure a bunch of different services or do kind of all of that stuff, you can build all of these things together and then push the container up to AWS or push the container up to Azure, and it'll kind of just run, and it'll take care of all the dependency management and the operating system management for you. So it's really useful when you're working in teams or when you need to deploy things out to the cloud. One of the things I didn't get to show today, because I think it's a little complicated and I didn't want to overwhelm y'all, is we have this tool called Docker Compose. So Docker Compose is like the next level of what I showed you, and Docker Compose lets you do multiple builds at a time. So let's say I have one container that's running my Flask app, and I have a second container that's got my MySQL caching server. That means I'm going to need to do 2 Docker builds. So I'm going to have a build for the Flask app and a build for the database. And those are going to have to be different because the database is going to need to use those volumes that I did before. So like it needs persistent storage, while the Flask app doesn't need persistent storage. So the build there is going to be like, yeah, don't use volumes. We don't need volumes. We're too cool for volumes. And so you can use Docker Compose to go in and say, okay, I want you to build these 2 things together, and I want you to turn this service on for me. So then you can use Docker Compose up, which will go out, it'll build your stuff for you, or if it's pre-built, it'll just start running it for you as well. And that way you can get all of these services running at the same time on your local machine, rather than having to, open Postgres, open your terminal and run Python, open this, that, and the other. And it's really useful when you start to use a lot of different things in your application all at once. Maybe you need to run a load balancer on top of it. Maybe you need Gunicorn or something like that running too. And so you're able to get all of these things running and kind of make sure that it's as close to the real thing as possible. Because when you do go eventually and push it up to the cloud to live out there, you're largely just going to be pushing that code base, and it's going to be using that compose file to build and set everything up for you, which also will make debugging it a lot easier. Because one of the worst things to have to debug is like, yeah, it works on my machine, but it doesn't work on the cloud. What's the difference here? And Docker kind of helps reduce that burden as well. So that was a great question. That's a really great question. I hope that answered it for you. I hope that was useful. Difference between containers and pods. I'm not sure what a pod is, so I can't really answer that, unfortunately. So maybe Google is the best version for that. Okay, the difference between native hypervisor and hosted hypervisor. I also don't know the answer to that question, so let me Google it. Let's see what Google says. But I imagine that is also going to be complicated too. So it says native hypervisor is a more secure option, unlike a hosted hypervisor that does not depend on the underlying operating system. So if you're under attack, you have a better chance with a bare metal hypervisor, but it does cost a bit of efficiency, performance, and speed. Yeah, I think that's well beyond my knowledge. So I'm going to defer to Mr. Google and Stack Overflow on that one as well. There are hoodies and t-shirts in the store. So the coupon code will get you will cover enough to get a t-shirt and shipping as well. So I would pick any t-shirt. It needs to pay $17 for delivery. Oh no, I think that means I set the coupon code to only cover shipping in the US. I will go and update that right now to do a version that'll cover shipping a little further as well. So give me 1 second. I'm just pulling up my swag store, and I can make it a little coupon code for folks that need a bit more for shipping as well. So give me 1 second. I know it's different for everyone, but just asking on average. How much time does it take to learn Docker from beginning to intermediate? That is a great question. So I've been learning Docker kind of, I think Docker is kind of like skiing in some ways. I don't know if you've ever gone skiing, but I like to think of the metaphor of skiing is skiing versus snowboarding, right? So when you learn to snowboard, I'm a snowboarder, not a very good one, but I am one. So what I've been told is that okay, for most of the folks from India, this metaphor is not going to work. But with snowboarding, it's difficult to get started, but it's easy to master. Whereas with skiing, skiing is easy to get started, but it's hard to master. And I think Docker is kind of in that similar veins. I think Docker is really easy to get going with, to get building things, to run containers, to do stuff, and then it gets a little more challenging as you get into more specifics and more DevOpsy stuff, and that gives you a bit of work. So I think going from a beginner to an intermediate Docker user is a pretty fast journey, but going from an intermediate Docker user to a master Docker user, I think is a little tougher, and you really need to be spending your time reading and experimenting and making things as well. But I think getting use out of Docker straight away is really helpful, or is really easy straight at the beginning. So let me just add this discount code. So I'm going to use MLH GHD India, and I can do, you said it's $17, so let me just add that to my store. Sorry about that. I kind of just assumed shipping worked the same for everyone. Cool. Asia. Cool. And set it to expire on Monday. There we go. Okay, cool. So I'm going to text the coupon code for the further shipping, and if Mary could chuck it in the comments, that would be really helpful too. So yeah, hopefully that fixes it. Cool. Thanks, Mary. I really appreciate it. So you can use that same link on the Swag store. That should hopefully cover the difference in shipping. Cool. Philomath asks, "Where's the coupon code?" It's on screen or it's in the chat. Yeah, and so I think that's all the questions. So unless you all need anything, I think maybe I can let you all go. We're coming up on an hour. Mary, is there anything coming up that maybe you wanna tell people about? Any new workshops that are in the schedule or anything like that you want to share?
Of course, I'll hop on real quick.
Not to put you on the spot there, but
No, that is A-okay. We do have a session coming up right after this. Let me double check my schedule to make sure I don't name the wrong one. So we have Isabel coming up with a Create a Business Plan live stream. So she's going to be walking you through how to create a business plan. She's had a lot of startup experience.
yeah.
So that'll happen in 8 minutes from now.
8 minutes. Oh,
Yes.
wow. All right. Well, we should probably hop off a little early so people can get a bathroom break before that next session.
Amazing. Cool.
Yeah.
Thank you so much, Shai.
No worries. Thank you for having me. I had a lot of fun. I always love coming back to do MLH stuff. Hackathons were such a huge part of my journey into computer science and becoming a professional software person. And so I'm always excited to be here and get to give back. So thanks for the opportunity on that.
Of course. All righty. I'm going to end this stream. I will see you all back here in 8 minutes.
Bye, everyone.
Bye, everyone.